So section 1.4, we're going to deal with one-sided limits. So I'm going to give you an example. If I want to take the limit as x approaches 0 of the square root of x, okay? A, can we use direct substitution? Yes, because I can shove in a 0 and the square root of 0 is 0. Perfect. What happens, though, if I graph this thing? Because remember, you got to come at it from the left and from the right. So if I graph this and I come at my target x value of 0, if I come at it from the left, there's no graph for me to be looking at. Okay? So now, hang on, if I come at it from the right, I've got a graph to follow. And so in this case, if you're going to do this graphically, we technically have to do this as a one-sided limit. So if I were to say use the graph to determine the one-sided limit. Now, how do I know which side you're going to tell me? So it's going to look like a little exponent above the value that you're tracking. So instead of saying as x goes to 0, which applies from the left and the right, I'm going to say take it from the right. And we say from positive world. Because in general, your positives are to the right and your negatives are to the left. Okay, so if I want to be from the right, I'm going to say positive. If I'm going to be from the left, I want this to say negative. So it's up in the substitution area. Or what? It is up in the exponent area. And all you do is say, okay, I'm going to take the limit as this thing comes in from the right. So now, what y value am I creeping up to as I creep up only from the right? Well, I'm coming up on 0. So now I can technically do that answer. Okay? So now we're going to look at a few of these, and this actually helps us explore continuity or the continuousness of our graphs. So here I go. I've got, tell me the x value. If my c value is 8, so again, here's this, okay? This first one says find the limit as x approaches c with a little plus sign. So it says as x approaches c from the right. So as I come at an x value of 4, or of 8, good heavens, from the right, I get an answer of 4, okay? Happy clam. All right, as I come at an x value of c from the left, or an x value of 8 from the left, that's why it's a little minus sign, we'll just come at it from this way. So from the left, as I creep closer to an x value of 8, what y value am I creeping up to? I'm creeping up to 4. Well, does 4 equal 4? Yes, it does. So what is the limit as x goes to c? So I don't care from the left or the right, they've got to match. So in this case, it's 4. Okay? So these are called, again, one-sided limits. One-sided, either left or right. Okay, so is it continuous at x equals 8? Well, what was my original picture? Was it continuous? Did I have to pick up my pencil at all? No, it was fine. So is the function continuous at x equals 8? Yes, it is. Okay, if there's a hole or if there's an asymptote, that's where you're going to find issues, okay, as far as continuity goes. So let's do another one. All right, we have the limit as x approaches c from the right or from the positive side. Okay, so again, I'm in negative world. Don't let that throw you off. This just means from the right, okay? So what is my value for c? c is negative 4. So as I look at negative 4, it's right here. So as I creep at it from the right, what y value am I creeping up to? Creeping up to 4, okay? As I creep at it from the left, which is a little negative sign, okay, what am I creeping up to? Still creeping up to 4. What is the limit as x approaches 4, or negative 4? It is 4. That's your limit. Okay, now, is it continuous? Okay, so what happens? I draw this part of the graph, and I hit right here, and I've got to pick up my pencil and fill in this point, pick up my pencil, and then fill in the rest of this thing. So here's what you want to know. If the continuity is in question, okay, so is it continuous? Then your limit from both sides has to exist, and it has to give you the same number. Okay, so if it exists from the left and it gives you negative 32, and it exists from the right, it gives you a 100, you know immediately that it's not continuous. But from the left, this was 4, and from the right, or I just did that backwards. From the right, this is 4, and from the left, this is 4. Everything's fine. But then, does the value exist, and is it also the value you just got? Because when I actually look at this one, when I shove in a -4, I got a 6. Okay, so if the limit, which is 4, matches the value, which is 6, then it would be continuous. This is not continuous. I had to pick up my pencil to draw the picture, so he's a no. All right, so find the limit. So x approaches 7 from the right. Again, you can use direct substitution on these if available. So I'm going to rewrite this as a -x minus 7. So I've factored out a negative. So that became a -7 plus x. And then I just rewrote it in the same order. And then I've got x plus 7, x minus 7. So those reduce out. Now can you use direct substitution? So it's a 7. And since my goal is direct substitution, then it doesn't matter which side I'm coming from. There will be times it will. But on this one, go ahead and shove in a 7. Not a do you understand? This little plus thing means from the right. All right, so I've got 7 plus 7, which is going to give me a -1/14. Okay? All right, let's try another one. This you have seen before. I told you he was back in section 1.2. And what he looks like is absolute values. And here is +9, and he shoots out this way. And here is +9, he shoots out that way. So I want to come at 9 from the positive side. Okay? And what we might want to do is I might want to show you how to do this on your calculator. So I know I wrote it down before, but let's actually look at it this time. So if I hit y equals and clear this out, if you hit math, I really wish that this would see better. Ooh, look. All right, hit math and scroll over to num, which is numbers. And then 1 is your absolute values. Okay, so there's my absolute values. I am looking for absolute value of x minus 9. Okay, and I need that to be divided by, so use parentheses, x minus 9 without absolute values. So basically you can see that this is essentially a number divided by itself. The problem is on the top, it's going to be positive all the time. On the bottom, depending on what you get, it's either going to be positive or negative. Okay, so my answer, when I just kind of sort of figured it out just by reason, that regardless of what value I put in for x's, as long as it's not 9, okay, I'm going to get either a +1 or a -1. So when I graph this, hit graph, all right, so here this thing comes, you can't see. All right, so that's coming in that way, and it's going to stop and then hop up, and you can see it's going to start back in over here on top. So this question says, as I come at 9, which is my target right here, from the right. So I'm coming at 9 from the right. What's your limit? So coming at 9 from the right, my limit is a +1. Okay, if it asked for the limit as x approaches 9, it would not exist. But if I put a negative here, I can do that because I'd be coming from the left and I would get a -1. If I put a positive, I can come at it from the right and I'd get a +1. So that's why we're doing one-sided limits. We can get a little bit more information from that. So this one does exist and it's a 1. All right, so this one. So now you want to be lazy math people. I want to find the limit of f of x as x approaches 5. Okay, so step back and look at this. This is a piecewise function. This is a parabola, okay? And it looks like an upwards parabola if I'm to the left of 5. It looks like an upside down parabola if x is to the right of 5. And so a parabola, its domain is all real numbers. An upside down parabola, its domain is all real numbers. The only issue I'm going to have is where one stops and the other one picks up. If they stop and pick up at the same place, then the limit exists. If they stop and pick up at different places, the limit won't exist at that value. Okay, but right now the limit exists at every value in the whole wide world except for possibly 5. So what's the fastest way to go? We're going to use direct substitution. So if I shove in a 5, that gives me 25 minus 10 is 15 plus 7 is 22. So the point 522, I'm not allowed to use the 5, so I'm approaching 522. Okay, I hope that makes sense to you. All right, and I'm going to check my math because I'm zoning. I've got 25 minus 10 is 15 plus, there we go. All right, so this one I'm going to put in a 5 again. So negative 5 squared is 25. So I get a negative 25 plus 10 is a negative 15, okay, plus 37. Well, 37 minus 15 is, guess what? 5, 22. So what you find out is as soon as this one ceases existing, so what you're finding out when I creep at it from the left, I can't touch that 522 because it's untouchable. It's not included. But I can use 4.9 and 4.99 and 4.999 and 4.9s for a whole lot of infinite nines. And guess what value you're going to creep up to? You're going to get awfully close to 22. So since evaluating them both gave you a 22, the answer is it does exist, and your answer is 22. Okay? It also means that this entire thing is continuous. Because right side up parabola is continuous, upside down parabola is continuous, and then they meet as soon as this one ceases existing, this one picks right up. You can't even tell the difference. Okay? This one, what is this? So this is a step function. Okay? So you're used to seeing this. It's hard brackets with a double vertical bar. And if you've seen it, it looks like stair steps. So we actually very lazily call it the step function. Okay? So that's supposed to be open circle. All right, so here's what I want to know. What it means is this. I need to show you how to generate one of them to begin with. Whatever x value I give you, the corresponding y value rounds down to the nearest integer. Okay? So if I give you 0, well, 0 is already rounded, so that means 0, 0 is on the graph. If I give you 0.1, round down, I get 0. If I give you 0.5, round down, I get 0. If I give you 0.9, okay, round down, I get 0. What happens if I hit a 1? He's already rounded. So it got 1, 1. So here's what we just did. 0, 0 is there. All the decimals between 0 and 1 are also there. But as soon as I hit 1, I got to jump up and start plotting here. Okay? Then there's all the 1.1s and whatever. And then I'm going to jump up when I hit 2. That's what it means. So, can I use direct substitution? Yes, I can. I'm going to come at 4 from the right. So that's what's going to be important, because if I'm coming at 4 from the right, it's going to tell me how to round. So first of all, can I shove in a 4 to 7 times x? Yes, I can. Minus shoving in a 4 from the right side. So if I use anything close to 4 from the right, so if I use 4.1, 4.2, 4.3, it doesn't matter. It's going to round down to 4. So this whole thing turns into a 4. So I get 28 minus 4 is going to be 24. Okay? So, a couple more things. It says, I'm trying to only do this one in two videos. That's my goal. All right. Discuss the continuity at x equals. I just underlined the wrong thing. Discuss the continuity of the function. Okay, so I have a straight line, but my function is a parabola, so I'm kind of confused. Remember that this is an x plus 2, x minus 2, because it's the difference of 2 squares, over x plus 2. Any number divided by itself is 1. And so what do I have? I actually have a linear equation of y equals x minus 2. So he slices through the y-axis at -2 and has a slope of 1. But what's the difference between this thing and this thing? We hit this in another video already. This one has a hole. This one has a hole at -2. Because at -2, -2 plus 2 will make your denominator equal 0. Okay, so he has a hole right there at -2. So can I draw this line without picking up my pencil? No, I had to pick up my pencil to hop over that hole. So you have a discontinuity. You got either a hole or an asymptote. So he is discontinuous at -2. Okay, so where did you pick up your pencil? You picked up your pencil at -2. All right, so I would like to know about these. No, I don't. I have to wait. All right, so we'll finish this up. I can finish this up in one more video, I think.